Hello students, today we are going to start imidazole as a heterocyclic compound. It is the structure of imidazole. This nitrogen pyridine like nitrogen and this nitrogen pyrrole like nitrogen. Here is the structure of imidazole. This lone pair is the sp2 hybridized orbital and here unhybridized p orbital. Now see the properties of imidazole. First see the aromaticity. Imidazole have 3 carbon and 2 nitrogen. All are sp2 hybridized. sp2 hybridization is planar. It makes a planar imidazole ring structure. Each ring atom also contains unhybridized p orbital that is perpendicular to the plane of sigma bond. Here p orbitals are parallel to each other, so overlapping between p orbitals is possible. The total nucleophile of non-bonding electron are 6, 3 of 3 carbon, 1 from 1 nitrogen and 2 of other nitrogen. The resonance of 6 electron follows the Hockel rule. So, the second property is tautomerism. Imidazole with a ring N hydrogen are subjected to tautomerism. Here is the imidazole 4,5-methyl imidazole. Tautomerism structure is here. 4-methyl imidazole equilibrium with 5-methyl imidazole. Third property is the hydrogen bonding. The two structure of imidazole and this nitrogen hydrogen and nitrogen hydrogen bonding, here is the hydrogen bonding. Now see the synthesis of imidazole. First is the synthesis of imidazole from a dicarbonyl and aldehyde and ammonia. The reaction of complete in 2 stages. Now see the synthesis of alpha halocarbonyl compound. Here is the alpha haloketone on reaction with amidine Lu minus Br to give substituted imidazole as the product. Now in second reaction, alpha hydroxyketones in presence of amidine loss of water to give substituted imidazole as the product. From dehydrogenation of imidazoline, condensation of 1,2 amines with nitriles gives imidazoline. Imidazoline reaction with barium magnet yield 2 substituted imidazole as the product. Here is the 1,2 diamines on reaction with nitriles, loss of ammonia to give imidazoline as the product in presence of barium magnet to give this structure. Now see the electrophilic addition to carbon. First one is the protonation. Basic property, imidazole accept proton, act as a base. Here is the lone pair of nitrogen abstract this H plus to give NH plus. It is the imidazolium cation. Now see the N-alkylation reaction. Imidazole on reaction with alkyl iodide to give this structure. Now in next structure, imidazole as a base remove proton. That's why these hydrogen are abstract by imidazole base. Now see this structure and this lone pair of nitrogen also attack on CH3 and iodine group are leave to give N1N3 dimethyl imidazolium salt. Now see imidazole react with alkyl halide and first gives N-alkyl imidazolium salt. This salt can lose an N proton in an equilibrium with unreacted imidazole generating N-alkyl imidazole. N-alkyl imidazole react with alkyl halide and gives N1N3 dialkyl imidazolium salt. Now see the electrophilic substitution of carbon. In imidazole, 4th position and 5th position are favored position C2 substitution not favorable as it form highly unstable N+. Now see the electrophilic substitution reaction, nitration reaction, sulfonation reaction. Nitro group is attached to the fourth position. In sulfonation reaction, SO3H group also attached to the fourth position. Now see the halogenation reaction. Imidazole on a reaction with Br2, HAC, NaC to give this product, here Br2, that's why 4 and 5 position bromine group are attached. In presence of aqueous Na2SO3 to give 4 bromo 1 hydrogen imidazole. Bromination gives 2,4,5 tribromo imidazole. 4,5 bromo imidazole can be obtained by reduction of tribromo imidazole with sodium sulfite. Now see the imidazole catalyze ester HL. Imidazole group of histidine residue present in hydrolytic enzyme function as ester HL. Imidazole as a base catalysis activates water for attack at carbonyl carbon. Here is the imidazole lone pair of nitrogen abstract this hydrogen atom. Now in next step lone pair of oxygen attack on carbonyl group and here is the O-. This O- revert back and this carbon oxygen bond are break and forms acid as this structure and side product is the O- R. Now see the imidazole as a nucleophilic catalysis. Imidazole directly attack at carbonyl carbon. This lone pair of nitrogen attack on carbonyl carbon. Here is the O-. This O- revert back and oxygen carbon bond are break. This now see this structure. Now in next step -H+. This bond shift here and this bond stabilize positive charge on nitrogen atom. Now in next structure in presence of water lone pair of oxygen attack here and this carbon nitrogen bond are break and imidazole as the final product. Thank you so much. If you like this OD video, please like, share and subscribe my YouTube channel.